Okay, so let's look at this example here and let's revisit the process of factoring. So always remember the very first step we do is we always look for a greatest common factor. And even here, why? Why do we do that? Because we're going to have to end up factoring out the greatest common factor anyway. Somewhere along the line, as we factor this out, we're going to have to deal with the greatest common factor anyway, and it's going to end up getting factored out. So why not do it at the beginning? And it's always better to do it at the beginning because it eliminates, or not eliminates, but reduces the number of combinations you have to work with greatly. Okay? So in this example here, we can see that we have a common factor of 2. So let's factor out the 2 first before we go any further. And so now you see that now we've got this, and it's got a leading coefficient of 1, which is great because now we can use our method that we learned before. So now all we can do is look at the factors of -4 that add up to 3. And since 3 is positive, this is going to have opposite signs where the larger factor is positive. So what are those 2 factors? It's going to be what? 4 and -1. And so this is going to be x plus 4 times x minus 1, and we're done. Now, notice that these are all prime factors. Okay? And so again, that's the way we want to do this. Always look for a greatest common factor. There might not be one, but look for the greatest common factor and factor it out in the beginning, and then see what you have left over and see if it's factorable. Okay? We'll come back and do another one.